Okay guys, let's begin the discussion over the questions. The first question says that there is a curve passing through 4, 5 and satisfying this given integral equation. Now, what is that curve? If I talk about this 0 to x, t, y is a function of t, dt equals x square y. When I talk about basically differentiating this, I get what? I get xy equals x square dy by dx plus y into 2x. I just applied the chain rule. Now what you get is xy minus 2xy equals x square dy by dx. This gives you minus xy upon x square equals dy by dx. Right? From here you get minus y by x equals dy by dx. Or you can say dx by x equals dy by y. Here it is a minus sign. Right? Now you know this is variable separable. You just need to integrate. What you get is minus ln x equals ln y. Right? And you can say this is ln x plus ln y, which is ln xy. Right? And you can just write over here ln c. Or if you want, you can write this side, because you know how to basically resolve this too. So you get ln x plus ln y equals ln c. You know that this is a 1, 1 function and therefore xy equals c. But it is given that the curve is basically passing through 4, 5. So when x is 4, y is 5. That 4, 5 is going to satisfy the equation of this curve. So x is 4, y is 5. You get c is 20. Therefore xy equals 20 is the required equation of the curve. Xy equals 20. Clear? Moving to the next one, we have that f be a differentiable function with limit at infinity being 0. If this is 0, limit of x tends to infinity, y of x is also 0, then which among the following is true? Now if you observe this carefully, what is this trying to say? It is saying y dash plus f dash x into y equals fx f dash x. And what is this y dash? It is dy by dx. So it's dy by dx plus py equals q. Linear differential equation. Solve it. Very easy. Integrating factor is e to the power integration of p dx, which is e to the power fx. And then you know the solution is y into integrating factor is equals to integration of q into integrating factor dx plus c. Right? Now what you do in order to resolve this integration is you basically take t equals fx. When you do this, you get dt equals f dash x dx. When you get dt equals f dash x dx, you basically eventually get, this is something that you have, is equal to integration of e to the power t into t dt. Because f dash x dx completely is dt, fx is t, e to the power fx is e to the power t. Now you know this is going to act as the first and this as the second function according to the rule of Eilate. So you have first number into integration of second minus integration of differentiation of first into integration of second dt. Then here you have t e to the power t minus e to the power t plus c obviously. And here you have y e to the power fx. Resolve this, you get t is what? Fx e to the power fx minus e to the power fx plus c. Now you can write this as what? You can write this as e to the power fx can go that side and become e to the power minus fx. So you get fx e to the power fx into e to the power minus fx is e to the power fx minus fx, which is e to the power 0, which is 1, minus e to the power fx into e to the power minus fx, which is e to the power fx minus fx e to the power 0 again, which is 1 plus c e to the power minus fx. Now it is saying that limit x tends to infinity fx is 0 and limit x tends to infinity yx is 0. Let's just apply limit x tends to infinity. So you get limit x tends to infinity y of x equals limit x tends to infinity f of x minus 1 plus c e to the power minus limit x tends to infinity f of x. So this becomes 0 equals 0 minus 1 plus c e to the power 0, which is 1. So c comes out to be 1. The moment c has come out to be 1, you have got your very equation, which is what? If I talk about this, this becomes y. So this is something that you have to take into account. It is y equals fx minus 1. Y equals fx minus 1 plus c is 1 e to the power minus fx. C is 1 e to the power minus fx. So you get y plus 1 equals e to the power minus fx plus fx. Okay? So y plus 1 e to the power minus fx plus fx. This happens to be the correct option. Moving to the next one, what is it that we have? Let's see. Question is about solving this given differential equation. Let's talk about the solving of this differential equation. Now in here, very easily it's given dy by dx whole square minus dy by dx multiplied by e to the power x plus e to the power minus x plus 1 equals 0. Very easily you can write this as dy by dx minus e to the power minus x multiplied by dy by dx minus e to the power x equals 0. The same differential equation is going to turn out, and therefore for this to be equal to 0, this is 0 or this is 0, right? Fine. So from here you get dy by dx equals e to the power minus x, and from here you get dy by dx equals e to the power x. Now here obviously you can separate the variable. This is e to the power minus x dx and this is e to the power x dx. When you integrate, you get y equals minus e to the power minus x plus c, and next one you get y equals e to the power x plus c. So y minus e to the power x equals c and y plus e to the power minus x. Y plus e to the power minus x equals c and y minus e to the power x equals c is your correct options. Moving to the next one, we have what is the solution of this differential equation. Okay, so something like this we've done. It is completely directly based on that concept. What is it? Let's try to understand. Here the moment I see x plus y plus 1 dy equals dx, I decide to take x plus y plus 1 to be equal to u. From here you get 1 plus dy by dx plus 0 equals du by dx. So dy by dx becomes du by dx minus 1. And therefore this becomes what? X plus y plus 1 is u, dy by dx is du by dx minus 1 equals 1. So this is what you get. Now this gives you u du by dx minus u equals 1. So from here what you get is, let's see, you have u du by dx equals u plus 1. Okay, so u upon u plus 1 du equals dx. Variable separable. So this is u plus 1 minus 1. So it is 1 minus 1 upon u plus 1. I can write like this. because this is u upon u plus 1. So this is integration of this du equals integration of this dx, which becomes u minus ln of u plus 1 equals x. So you get ln of u is x plus y plus 1 gives you this. This gives you u minus x. U minus x. U is x plus y plus 1 minus x, which is y plus 1. Right? Plus c, obviously, the constant. Or what I can say is this only. 1 plus some constant is some other constant. So you get ln of x plus y plus 2 is y plus some constant, which is this. Now if you solve this, what you get is x plus y plus 2 equals c into e to the power y. I can write it like this. Now it is given to you that y of 0 is 0. If y of 0 is 0, when x is 0, y is 0, this is also 0, you get c equals 2. And therefore your solution is x plus y plus 2 equals 2e to the power y. Your answer is x plus y plus 2 equals 2e to the power y. Then you have twice of this minus this equals 3 by 2, right? So you have, consider this is twice of integration 0 to 1 e to the power y. This minus integration 0 to 1 y dy equals, so this is minus of this equals integration 0 to 1 x plus 2 dx. Right, because 2e to the power y minus y is x plus 2. So I am just integrating from 0 to 1 everything. Here I get 2 times, or let me just not compute the left hand side because that is what the value I want to find. This is x square by 2 plus 2x from 0 to 1. This gives you 1 by 2 plus 2, which is 5 by 2. And therefore you are not getting this coming out to be 3 by 2, even this is wrong. Moving to the next one, we have the orthogonal trajectories of the system of curves, which is this, is given by what? Let's see. Now you have dy by dx whole square equals a by x. Already you have dy by dx with you. You know the drill. You need to replace dy by dx by minus dx by dy. So when you replace, you get minus dx by dy whole square equals a by x, which gives you dx by dy. Dx by dy, because this is 1, this gives you a to the power 1 by 2 upon x to the power 1 by 2. So dy by dx is x to the power 1 by 2 upon a to the power 1 by 2, which eventually gives you dy equals x to the power 1 by 2 dx upon a to the power 1 by 2. Variable separable integrate. You get y equals 1 upon a to the power 1 by 2 outside, x to the power 3 by 2 upon 3 by 2, which means into 2 by 3. Plus some constant, let me add that constant here, not a problem. So you get y plus c equals 2 by 3, x to the power 3 by 2 upon a to the power 1 by 2. Square both sides, you get y plus c whole square equals 4 upon 9a x cube. So you get 9a times y plus c whole square equals 4x cube. What do you get? 9a times y plus c whole square equals 4x cube. Clear? Moving to the next one, what is it that we have? Let's see. The differential equations for which the solution is given in column 2. Basically, differential equations are given in column 1 and their respective solutions are given in column 2. Each of the solutions is requiring the computation of the second derivative. So let's talk about the first case. Y is a e to the power 3x plus b e to the power 5x. dy by dx will be a 3 times e to the power 3x plus 5b e to the power 5x. Now if I say that this is equal to 3 times y, this will be 3 times a e to the power 3x plus 3 times b e to the power bx. But I have 5 times this, so I am going to add 2 times b e to the power 5x. In that case, then if I compute again the differentiation, I get 3 dy by dx plus 10b e to the power 5x, which is 3 dy by dx plus 5, you can write it as 2 times b into e to the power 5x, but 2 times b into e to the power 5x is dy by dx minus 3y. So you basically have d square y by dx square, 3 dy by dx plus 5 dy by dx is 8 dy by dx. So d square y by dx square y2 minus 8 dy by dx plus 15y equals 0. Right? So you have Q being shaded against A. Next you have what? Let's see. B. That is my B. So I have xy equals a e to the power x plus b e to the power minus x plus x square. Okay. So here if you differentiate, you get first number differentiation of second plus second d by dx of x is 1 only. From here you get a e to the power x minus b e to the power minus x plus 2x. Again differentiate, you are everywhere requiring the second derivative. So first differentiation of second plus second differentiation of the first plus dy by dx equals a e to the power x plus b e to the power minus x plus 2. Now a e to the power x plus b e to the power minus x is xy minus x square. So I can write this as this much portion, xy minus x square plus 2. Okay, so you are getting what? xy2 plus y1 whole square. This is dy by dx plus dy by dx. This is 2 times dy by dx. So twice of y1 minus xy plus x square minus 2 equals 0. So you are getting this, that is R against B. And the last one you have what? Let's see. Last one is y is equal to a sine 4x plus b. Okay. So dy by dx becomes what? A cos 4x plus b into d by dx of 4x, which is 4. Next again if you integrate, again if you differentiate, you get 4a into 4, which is 16, and then you have minus sine 4x plus b. But sine of 4x plus b, a times sine of 4x plus b, this much is y, so you are getting y2 equals minus 16y, or y2 plus 16y is 0. So you shade this. Moving to the next one, we have the curve satisfying this differential equation passing through 2, 1 is a parabola with focus 1 by 4, 0. Let's see if it is or not. So you are given dy by dx, y dash is dy by dx equals y by 2x. So you are getting dy by y, or twice of dy by y equals dx by x. So you get ln y, twice of ln y or ln y square equals ln x plus c. Right? So you basically get, or let me write it as ln c. So from here you get ln y square minus ln x, which is ln of y square by x equals ln c. So y square by x equals c, which is what? Now over here you can see it is passing through 2, 1. When x is 2, y is 1, c is coming out to be 1 by 2. So you are getting y square equals 1 by 2x, which can be written as y square equals 4 into 1 by 8 into x, which is a parabola which is having focus as 1 by 8, 0 and not 1 by 4, 0. So statement 1 is false, and it is saying this differential equation y dash equals y by 2x is of variable separable type. So yes, it is. So I get that statement 1 is false, but statement 2 is true. Moving to the next one, we have paragraph question. The first para is basically giving you the meaning of orthogonal trajectory, okay, and then it is asking you to compute the orthogonal trajectory. So orthogonal trajectory for y equals cx square, I can write this as y by x square equals c. Now differentiate, you get second number into dy by dx minus first number into 2x upon x square whole square. D by dx of c is 0. So you get x square dy by dx minus 2xy equals 0. After this I can say dy by dx is 2xy upon x square, which is 2y by x. Fine. Now that you have got this, I can say this means dy by 2y equals dx by x. So this implies 1 by 2 ln y equals ln x, isn't it? Or rather than that, if I don't talk about this solution, I have got dy by dx equals 2y by x. For orthogonal trajectory, we basically replace dy by dx by minus dx by dy. This becomes equal to 2y by x, which implies dy by dx turns out to be minus x by 2y. Now when you differentiate, now it's the time to differentiate, you get 2y dy equals minus x dx, and now when you integrate you get 2y square by 2, which is minus x square by 2 plus c, which is very clearly representing a family of ellipses. If I talk about the next one, under the same paragraph question, it is now giving me another curve. Let's talk about its orthogonal trajectories. Y equals c e to the power minus x. I can write this as this. Again it is y, differentiation of the second, plus e to the power x, differentiation of the first, equals 0. So you get y e to the power x equals minus e to the power x dy by dx. So you basically from here get y e to the power x upon e to the power x, which is minus y equals dy by dx. Now you replace dy by dx by minus dx by dy. So minus dx by dy equals minus y, and therefore dy by dx is going to turn out to be 1 by y. Minus minus cancels, dy by dx is 1 by y. So you get y dy equals dx, or y square by 2 equals x plus c. This is again very evidently representing the family of parabolas. Fine. Next we have y is given to us as e to the power 4x plus twice of e to the power minus x. It is given that it is going to satisfy this differential equation. Then what is the value of 1 by 39 times a into b? So this equation is basically requiring third derivative, first derivative. So let's compute that. Y is e to the power 4x plus 2 times e to the power minus x. Y1 is 4 times e to the power 4x minus 2 e to the power minus x. Y2 is 16 e to the power 4x plus 2 e to the power minus x. Y3 is 64 e to the power 4x minus 2 e to the power minus x. Substitute it in this y3, first it is requiring. So 64 e to the power 4x minus 2 e to the power minus x. This is y3 plus a times y1. y1 is 4 e to the power 4x minus 2 e to the power minus x plus by. So plus b, y is e to the power 4x plus 2 e to the power minus x equals 0. Okay. So here you get e to the power 4x comes out common. You have 64 plus 4a plus b. Then you have e to the power minus x coming out common, minus 2 minus 2a plus 2b equals 0. Now you know that this is never 0, this is never 0, it's always positive. So for this sum to come out to be 0, this has to be equal to 0 and this has to be equal to 0. When you solve both these equations in a and b, you get a as minus 13 and b as minus 12. You want to compute 1 by 39 times a into b, which is 1 by 39 times minus 13 into minus 12. This is 3, this is 4. Your answer is 4 and the integer associated to this question is 4. And that completes our discussion over the questions. Practice them nicely. That's it from my side. Thank you.